This is OpenStax Calculus Volume 2. The other topics we discussed were in Volume 1. Now this topic, which is the differential equations, is in the second volume. So let's put our title. So this is Chapter 4, and it's like Introduction to Differential Equations. And we will start with basics of differential equations. So what is a differential equation? Differential equation is an equation involving an unknown function y equals f of x and one or more of its derivatives. We have some idea, we have some information how this function changes. Is it increasing? Is it decreasing? Because remember, derivative tells us about the rate of change in a function. A differential equation has that information. It tells us, it gives us information about how this function is changing, and then we would need to figure out what this function is. So a solution to a differential equation is a function y equals f of x that satisfies the differential equation when it is substituted. So when f and it is derivative or derivatives are substituted into the equation. So let's look at this equation. This is what we usually use to represent the function f of x, right? So y changes according to a formula which depends on the x values. So instead of f of x, we just use the derivative of this function y is 2x. So what is that function? Can you find the function whose derivative is equal to 2x? Another way of writing this question would be the derivative of the f function is 2x. So what is the function f? Now we learned the integrals, learned the antiderivatives. So you can find that this function should be the antiderivative of the 2x function. This is an indefinite integral. What would be the integral of 2x? So just take out the 2x dx. So 2 times the integral of x would be x squared over 2 plus c, which becomes x squared plus c. This equation, let's write that down. The differential equation tells us that the derivative of a function is 2x, and we find the solution to be that this function y equals x squared plus c. How can we check? So we talked about this. So when we plug in, when we substitute the function into this equation, it should be correct. It should satisfy the equation. So let's check y prime. So we should find the derivative of this function. So the derivative of x squared plus c, that's going to be decrease the power by 1. I put it to the front, which is 2x, and the derivative of c is 0. So in fact, we found y prime equals 2x, so it checks. Okay, so if you plug in the solution, so this is the solution y, so therefore we found that y equals x squared plus c, or the function f of x equals x squared plus c. This is a simple differential equation, and we just found a solution. By the way, the solution is a function, but in fact, as c changes, this function will change. So it could be x squared plus 1, x squared minus 5, x squared plus 3. So all these are solutions as long as you are not given further information in the question. So if this is the equation you have and you are not given any other information, you can just you should just say x squared plus c is the solution, and these are like specific solutions. You can just plug in anything for c. Let's talk about some definitions. So the order of a differential equation, it is the highest order of any derivative of the unknown function that appears in the equation. Let's identify the order of each equation. Y prime, so the derivative of y, minus 4 times the function y. So if you subtract 4 times the function from its derivative, you get this function in x. So we are not going to be solving this, at least not now, but we just want to find the order of this equation. So it is the highest order of the derivative. So we have some function in x, the function y itself, which is f of x, and we have the derivative of that function. So we only have the first derivative. So only the first derivative is in the equation. Therefore, the order of this equation is 1. So order of this equation is 1. Okay, this is the first order differential equation. X squared times y double prime, sorry, triple prime, minus 3x times y double prime plus x y prime minus 3y equals sine of x. What is the order of this equation? We have the function itself, f of x. We have it is first derivative, the second derivative here, and the third derivative, right? So this is a third order. So the order is 3. This is a third order differential equation. This is how you would denote the fourth derivative of a function y to the fourth inside parenthesis. So let's say 4 over x times the fourth derivative minus 6 over x squared times y to the second derivative equals x cubed minus 12. So let's say we have such an equation. In this case, this is the fourth derivative. So the order of the equation is 4. Let's talk about the general and particular solutions. In fact, we already started to discuss that idea. So this is a general solution in the previous example. And if you are given other conditions, other information, and you find out that C has to be 5 or anything else, then that is called a particular solution. X squared plus C is a general solution. We already said that. But how do we say? So we say this is, if C is 0, it is just the parabola. This is just C equals 0. Function is the x squared function. So if you take C equals 1, okay. So if you, let's say this is passing through 1, if you plug in 1 for C, you will find the function y equals x squared plus 1. So if you plug in C equals negative 1, the function will be x squared minus 1. So you can just have a family, as we said. So you can have a family of solutions. So this is a family of, these are family of functions which are all solutions. So we can say these are family of solutions. And if you have further criteria, one of them could be the particular solution depending on the other information given in the question. Okay, so if you leave it as C, then this is just set of solutions, a family of solutions. And if you just pick some number, if you determine the value of C, then that is going to be a particular solution. So let's see an example where we find a particular solution. So let's find the particular solution to the differential equation y prime equals 2x. Okay, so this is the equation that we already discussed. We are also given the information that this function passes through the point 2, 7. Okay, so we would like to find the particular solution to this equation where the function passes through 2, 7. So what does it mean? This is the x value and this is the y value. So we are looking for a function y equals f of x, where when you plug in 2 for x, y, which is f of 2, will be 7, right? So you can just, given a point that passes where the function satisfies, where it is graph passes through, you can say if you plug in 2 for x, y will be 7, so f of 2 will be 7. Okay, so we had already found that if the derivative is 2x, then the function would be, it is antiderivative, the indefinite integral, which is x squared, like 2 times x squared over 2 plus c, which is x squared plus c. So we had discussed this before. This is the general solution. Now just plug it. So let's write general solution and use this information to find the value of c. So what c has to be. You can also say f of x equals x squared plus c. Okay, so the same thing, whichever you prefer. So y, or f of 2, would be 7 when you plug in 2 for x. Okay, so it's going to be 2 squared plus c. So the particular, like the function that we are looking for, the particular solution, should satisfy this equation. So 7 equals 4 plus c. Therefore, c is 3. So the particular solution to this equation would be the function y equals x squared plus 3, or f of x equals x squared plus 3. Let's find the particular solution to the differential equation that y prime, the derivative of the function, equals 4x plus 3, passing through the point 1, 7. Okay, so we can first find the general solution to this equation. How can we find the general solution? If the derivative of the function is 4x plus 3, what would be the function? It's going to be the antiderivative of 4x plus 3. Okay, so what would be the antiderivative of 4x plus 3? So 4 times, just keep the coefficient. Now take x. This is x to the first. So increase the exponent by 1 and divide by that number. So this is the antiderivative of 4x plus 3, just keep the exponent, keep the coefficient, and the derivative of 1 is simply x plus the arbitrary constant of integration. So this will be 2x squared plus 3x plus c. So this function, this is the general solution to this equation. Now we should find the value of c by satisfying this information. Yes, plug in. So we should plug in x equals 1 and y equals, so if when we plug in x equals 1, y should be equal to 7, and then we will find c. So for what value of c this function will pass through this point. So 7 equals 2 times 1 squared plus 3 times 1 plus c. So 7 equals 2 plus 3 plus c, which is 5 plus c. So subtract 5 from both sides. So we find that c has to be 2 for the particular solution. So let's write that down. Y equals 2x squared plus 3x plus c, where we find c to be 2.